Good evening, dear students. So, in the previous class, we have started with the new chapter, that is carbon and its compound, right? So we have seen the electron dot structure in our previous class. So how to write the electron dot structures of some of the important compounds we have seen in the previous class, right? So then Then we have seen what are the types of compounds. So in the types of carbon compounds, there are two types of carbon compounds. One is the saturated, another is the unsaturated. So what do you mean by saturated? Saturated are the compound, that is carbon compound, which is made up of single bond. Okay, carbon-carbon or carbon-hydrogen bonds. Okay, so between the carbon-carbon, you have a single bond. Single bonds are present between the carbon atoms. Then they are called as saturated. And this class of compounds, they are called as what? They are called as alkanes. Okay, and we have seen the general formula. Okay, so the general molecular formula to represent the alkane, it is CnH2n plus 2. Okay, so as I've discussed, they have a single bonds between them, and the first member of this particular group, it is methane. Okay, it is a methane. Fine. Next is second class of carbon compound. They are called as unsaturated compound. So this unsaturated compounds means what? So the carbon-carbon bond will either have a double bond or it will have a triple bond between them. Okay. So if you have a double bond between the carbon-carbon bond, then they are called as what? They are called as the alkene. They are called as alkene. This class of compound, they are called as alkenes. Then the formula is CnH2n. Okay. And the first member of this group is ethene. Then if you have a triple bond between the carbon atom, then they are called as alkynes. Okay. So they have a triple bond between the carbon atoms, and the first compound of this particular first member of this series is ethyne. Okay, so this we have seen in our previous class. Moving further, then we had started with what are homologous series. So we were discussing about homologous series. Yes. So we'll proceed further. So what do you mean by homologous series? Okay. So as I've discussed, so series of organic compounds. So what? So these are homologous series, meaning what? They will follow a particular functional group. So this group or this series of organic compound, they'll have the same functional group, and the chemical properties and these members will differ by a CH2 unit. Between the first and the second member, or the second and the third member, this organic compound, they will be separated by, or they will be differing by a CH2 unit. Okay, and such a group or series, they are called as homologous series. So this set of compound, okay, they will follow a particular series. Okay, so they are called as homologous series. So they'll have the same functional group as well as their chemical properties will be same. Only the difference will be between the one CH2 unit. Okay, so we'll see the so this is a chart, what you can see here. Yes, you can you see the homologous series chart? Yes, so this is the particular chart. So in the first column, you can see the number of carbons. Okay, so number of carbons. So number of carbon means if the number of carbon is 1, okay, then 2, 3, 4, 5, depending on that. Okay, so this is the first one. Second one is prefix. What do you mean by prefix? Okay, so the word which is added before the your main parent name. Okay, so before the parent name, or you can say prefix. So the word before you add the name. Okay, so prefix. So you're adding it just before the your name. So it is called as prefix. What do you mean by suffix? It will end. Okay, prefix means it will start with this. Okay, prefix, it will start with this particular words, okay, which are given below. Suffix means it will end with this particular name. Okay, so this is the meaning of prefix and suffix. Next is structural formula. Okay, so based upon the number of carbon atom, their prefix and suffix, okay, what will be the structural formula? Okay, so how it what you can how it represents, okay, how it is, okay, how is the structure of this particular compound. Next is molecular formula. Okay, so what is the molecular formula of this particular compound? Like that. So when you have the number of carbon atom is 1. So when you have the number of carbon atom as 1, so what is the prefix used? It is meth. Okay, meth. Meth is the prefix. Okay. What is the suffix? Okay, when you have a saturated compound. Okay, saturated, as I have discussed, in saturated compounds, you have only one class, that is alkanes. Okay. So alkanes, that is, you have a carbon, single bond carbon. So all these compounds, they are made up of single bonds. Okay. So these alkanes, you can see it ends with ane. Okay. So the suffix will be ane. Okay. So the first, so whenever you have a alkane, the first member, when you have carbon atom as 1, the prefix is meth and the suffix is ane. Then the name is what? Methane. Okay. The name is methane. So what is the structural formula? Carbon in the center, okay, and 4 hydrogens. Okay, so this is your uh, methane. So the formula is CnH2n plus 2. So you can add N is equals to 1 here and you can check. So it becomes C1 and H4. Okay, right. So it is CH4. So what is the molecular formula? It is CH4. Understood? Yes. So when carbon is equals to 1, so what is the prefix used? Suffix will remain the same for the saturated alkane compounds. Okay, whenever you have a saturated compound, the suffix will remain the same. Fine. Okay. Moving further. Next is your, when you have carbon atoms 2, okay, number of carbon atom as 2, then the prefix will be in. What is the prefix? The prefix is in. Okay. Then the suffix is in. Suffix is what? In. Okay. So now you know what is the meaning of prefix, what is the meaning of suffix. Okay. So the prefix is eth, the suffix is in. Then, so you can add here. So when n is equals to 2, what will it will become C2H, 2 2s are 2 to the 4 plus 2 is 6, C2H6. Okay. So the molecular formula is C2H6. The name will be eth and the suffix is ane. So the name is ethane. So how will be the structure? So 2 carbon. Okay, then each carbon atom will be having 4 bonds. So this is the 4 bonds. Okay, so like this. Is it clear? So this is the structure formula of the ethane. This is the structural formula of the ethane. Understood? Yes. So when you have the number of carbon atom as 1, the prefix, as I've said, methane. Okay. The name will be methane and this is the structural formula and this is the molecular formula. Now, next is number of carbon atoms when you have 3. When you have 3 carbon atoms, okay, so you can use this formula CnH2n plus 2. So when n is equals to 3, so it will be C3H 2 into 3 plus 2. So add it C3H 2 3 is 6 plus 2 is 8. So it is C3H8. You can see the molecular formula when carbon is equals to 3, it will be C3H8. So what is the prefix? Prefix used is pro. Prefix is pro, and as it is a saturated alkane, it is ane. It is ane. Okay, now we'll write the structure again. 3 carbon atoms. Okay, so each it is attached by hydrogen. Okay, so this is joined by again hydrogens and hydrogen. Okay, so this is the propane. So you can see 1 2 3. Okay, 3 carbon atoms and 1 2 3 4 5 6 7 8 hydrogens 8. Understood? Yes. So remember the meaning of what is prefix, what is suffix. Okay. So you have to remember this. So what are these set of, so these are the homologous series. Okay. So these are the set of organic compounds which are belonging to alkane series. Okay. So this is the meaning. Understood. So what do you mean by homologous series? So these set of compounds which I am, okay, from the tabular column, so these are all what? These are the set of compounds, organic compounds, which are belonging to saturated compounds, that is from the alkane family. Okay, so these are from the alkane family. Fine. Next is when carbon is equals to 4. When carbon is equals to 4, what is the prefix? Prefix is but. Okay. And what is the suffix? It is ane. So it is butane. Okay. So add now carbon n is equals to 4 in this particular formula, CnH2n plus 2. So it is C4H 2 into 2 into 4 plus 2. Okay, so it is C4H, 2 4s are 8 and plus, so it is C4H10. Can you see? So the molecular formula is C4H10. What is the molecular formula? It is C4H10. Okay. So we'll write the structure now. C4H10. So 4 carbon atoms, 1, 2, 3, and 4 carbon atoms. Okay, so now we'll write the hydrogens. So there should be how many hydrogens? 10 hydrogens. So 1, 2, 3. Okay, then 1, 2. Count the hydrogens now. So it is C4H 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it is C4H10. Understood? Okay. So this is the structure of your butane. Now, when you have number of carbon atoms as 5, when you have number of carbon atom as 5, so N is equals to 5. So C5H 2, 5 plus 2. Okay. So just see what it will be. C5H 2 5s are 10 plus 2 is 12. So C5H12 is the molecular formula of this compound. The prefix is pent and the suffix is ane. It is pentane. Okay. So we'll write the molecular formula. We'll write the structural formula. So pentane means 5 carbon atoms. Okay. Now I'll arrange the hydrogens. Okay. I'll arrange the hydrogens. So 1 hydrogen, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay, so this is the structure of pentane. I hope this is clear. Okay, so like this, you have to write the homologous series. So this represents your homologous series. Okay, so these are the organic compounds which are belonging to what? These are belonging to alkenes. Okay, these are belonging to alkenes. Fine. So next is, so next you can say this column. Yes. Okay. So okay, after seeing this, so these are also the set of homologous series. Okay. But which organic so these organic compounds belongs to which family? Can you anyone tell me? Yes, students. Can anyone tell me these organic compounds they belong to which particular group? Yes. So these set, okay, these homologous series, they belong to which particular set, students? They belong to what? They belong to alkenes. Okay, you can see there is a double bond between the carbon atoms. So they belong to what? They belong to alkenes. Okay. So now here, so we'll see this particular series also. So when you have the number, okay, so this starts with carbon number 2. So, sorry, that is when you have C is equals to, you cannot write it for N is equals to 1. Okay, you have to write it for N is equals to 2. So it is not possible with 1. So we'll see with the N is equals to 2. So when N is equals to 2, that is number of carbon atoms are 2. So that time, how much it is? So when yes. So when number of carbon atoms are 2, okay. So what is the prefix here? So when we have seen it is ene, okay. So the prefix remains the same. Okay, so in the hydrocarbons, the prefix will remain the same. Okay, so the prefix remains the same. So it is eth. Okay, it is what? It is eth. Okay, now the suffix will change here because there is a double bond. Right, what you can see here, there is a double bond between the carbon atoms. So what is the formula? It is CnH2n. Right. So when N is equals to 2, C2H, 2 2s are 4. So it is C2H4. Okay. So this is a formula which alkenes follow. Okay. Alkenes follow this particular formula, general formula. So now when C is equals to 2, so C is equals to 2, then what will be the suffix? Okay, it will, the suffix followed by the alkenes are in. Okay, alkene. So in, E-N-E. Okay, E-N-E. So E-N-E. So it is ethene. So the molecular formula is C2H4. And how is the structure? So between the two carbon atoms, there is a double bond and there are 4 hydrogen atoms. So you can see this is the structure. Okay, so this is the structure. Understood? So this is the structure of ethene. Fine. Okay. Next is, as we have seen, when carbon atom is 3, that is CnH2n. So n is equals to 3. So carbon 3 and H 2 into 3. So it will be C3, H 2 3s are 6. Okay. So prop and ene. Okay. The, as it belongs to alkene. Okay. So the, it ends with ene. So propene. So the number of carbon atoms are 3. The number of carbon atoms are 3. So between any of this carbon atom, there will be a double bond. Okay. So now here, so C, H. So here one H, this one H. So number of carbon atoms are how many? 6. So I have to add 6 carbon. So 6 carbon atoms. So it is what? H, H, H. Okay, and here there will be one H. So 1, 2, 3, 4, 5, 6. I hope this is clear. Okay. So alkenes. So whenever you have alkenes, there will be a double bond. Okay. Next is when N is equals to 4. So add when N is equals to 4, what it will be? N is equals to 4. It will be C4H 2 into 4. Okay, so it will be C4H8. C4H8. You can see here C4H8, right? So now we'll write the structure of this also. So what is the prefix? Prefix is but and it ends with in. Butene. Okay, it ends with butene. Fine. Now we'll write the structure 1, 2, 3, and 4. So between any of the carbon, there will be a double bond. Okay, one carbon atom, there will be double bond. So now we'll write the structure. So 1, 2 hydrogen, 3, 4, 5, 6, 7, and 8. So this is the structure of butene. Okay. Next is, we'll write it for CnH2n when n is equals to 5. Okay. So n is equals to 5. So it will be C5H2 into 5. So it will become C5H10. Okay. So the name prefix is pent and it ends with in. Pentene. Okay. Pentene. So you can see the molecular formula pent and ene. So the name is pentene. Okay. The name for this particular compound will be pentene. Fine. Now we'll write the structure. The number of carbon atoms are 1, 2, 3, 4, and 5. So 5 carbon atoms. So between any one of the carbon, there will be a double bond. Now we'll arrange the hydrogen. So 1, okay, 2, then 3. See, carbon atoms will have 4 bonds only. Okay, so so you have to see the valency also. You have to see the valency also. Okay, you cannot write anything. So you have to see the valency. Carbon can have only 4 bonds. So you can see if I calculate this particular, when you see the valency of this. So how many this particular carbon has? Just see 1, 2, 3, and 4. Now again this carbon 1, 2, 3, and 4. Okay, again this carbon 1, 2, 3, and 4. So like that. So each carbon atom is bonded by 4 bonds only. Okay, you cannot write more than 4. So this is about pentene. Now next is CnH2n when n is equals to 6. Okay, so same it goes. This n is not restricted only till 5 and 6 carbon. Okay, it depends upon the number of carbon atoms. You can so you can write it till 20 also. Okay, the name is given till 10. So like that. So when n is equals to 6, so it will be C6H12. Okay. So the name is hex and the ends with hexene. Okay. Now the formula is C6H12. You can see here. Now we'll write the formula. So 3, 4, 5, and 6. Now we'll write the hydrogen bond. So any one of the carbon atom will have a double bond. So 2, then 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay, understood? I hope this is clear. So this is a tabular column wherein you have, so these organic compounds are belonging to alkene series. Okay, so this organic compound, they are belonging to which series? They are belonging to alkene series. Okay, so these are the homologous series of alkene. I hope this is clear. Okay, fine. Moving forward, next set of compounds. Okay, so these are the next set of compounds. So you can see in this, okay, there is a triple bond. So when you have a triple bond, these belongs to alkynes. They belong to alkyne. Okay, so the parent, that is the prefix, remains the same. Okay, as discussed in alkane and alkenes, the whatever the prefix were, the prefix remains the same. Only the reference will be suffix. So the suffix used will be YN. Okay, the formula is CnH2n minus 2. So this is a general formula for this. So this set of organic compounds, they they follow this, that is CnH2n minus 2. Okay. Now, same here, when n is equals to, substitute for 2. When n is equals to 2. Okay. Then it will be C2, then H2, 2 minus 2. So it will be C2H4 minus 2. It will be C2H2. Okay. So C2H2. So there are two carbon atoms. Between the two carbon atoms, there is a triple bond. Okay. And there are two hydrogens. There are two hydrogen. So this is the structure. So C2H2, you can see here molecular formula, and this is the structural formula. So I have written here. So this is the structural formula. What is the name? As I discussed, eth is the prefix and YNE will be the your what? YNE. What is YNE, students? YNE is the suffix. Okay, suffix. YNE is the suffix. Okay, fine. Okay, moving forward. Three, four, five, six. Have so these organic compounds are belonging to alkene series. Okay, so this organic compound, they are belonging to which series? They are belonging to alkene series. Yes. So moving forward, when carbon is equals to 3, okay, when you have number of carbon atoms as 3, so that time what you can see here, that so the prefix remains the same. Okay, so if you take this particular formula, that is CnH2n, so you add in that is CnH2n minus 2, and add n is equals to 3. Okay, then you get C3H4 as the formula. Okay, then you have three carbon atoms. So you have one hydrogen here, then 3, 4, and one hydrogen. Okay, and here the three hydrogen. So this is 1, 2, 3, 4. So this is what? Prop and YNE, propene. Okay. Then when you have number of carbon atoms as 4, if you add n is equals to 4 in this particular formula, that is CnH2n minus 2, then what you get? Okay, you get, as I said, the prefix remains the same. It is but, and YnE is when you have a triple bond. So you will get C4H6. Okay, when you add in this particular formula, that is CnH2n minus 2, you get C4H6. Now here in C4H6, now the number of carbon atoms are 4. Okay. So between any of one carbon atom, there will be a triple bond. So you have one, then here one. So hydrogens, hydrogen and hydrogen. So how many it is? 1, 2, 3, 4, 5, 6. Okay. So like this. So the name is uh, butane, then pentene. Okay. When carbon is equals to 5. 1, 2, 3, 4, and 5. So when you have a number of carbon atoms as 5, the prefix is pent, suffix is "-ine", and this is the formula, and this is the molecular formula. Then when you have the number of carbon atoms as 6, okay, when you have the number of carbon atoms as 6, the prefix is hex. What is the prefix? The prefix is hex, okay, and the suffix is "-ine". What is the suffix? The suffix is "-ine", okay. So you will be having 6 carbon atoms. The carbon atoms will be 6. So between any of the two carbon atoms, there will be a triple bond, and rest of the carbon atoms will satisfy its valency by 4. Okay, so you have C6H10. So like this. So what are homologous series? Okay, so we have seen here. So these are the what? So these are the series of organic compounds which will have the same functional group and chemical formula, and they are varying by only. So now, yes, now this how they are varying by CH2 group. So you can see here when you have CH4 and C2H6. Okay, just see how they are. What is the difference? The difference is C. Okay, so between C2 minus C is C, 1 carbon, then between C6 minus 4 is 2. So it is C2, CH2. So between the now, again, C2H6, okay, and C3H8. Just check now. So 3 minus 2 is 1, okay, and 8 minus 6 is 2. So again, right? So between each compound, there is a difference in CH2 unit. Okay, it is a difference of CH2 unit. So like this. Okay, so first set we have seen of alkane, second set we have seen of alkene, and the third set we have seen of alkynes. I hope you have understood about the homologous series. Okay. So you can see these are some of the compounds, okay, carbon compounds which we have written in ring. Okay, they are in ring form. They are represented by ring form. Now, till now we have seen what? We have seen the straight chain compound. They are called as straight chain compound. They are written in straight chain, okay, or in branched form. Now these are what? These are in cyclic form. These are in cyclic form, or you can say they are in ring form. Okay, now what is cyclopropane? So cyclopropane, you can write the cyclopropane like this. Okay, so this is a cyclopropane. Okay, so 3 carbon atoms. These are arranged in the what? Cyclic manner. Okay, these are arranged in what? These are arranged in cyclic manner. So these are the cyclopropane. Now, cyclobutane. So this is cyclobutane. So how this can be written? So 4 carbon atoms. Okay, like this. 4 carbon atoms and 2 hydrogens. Okay, you have to see that the carbons are satisfying its valency by 4. Okay, so this is the structure of cyclobutane. Next is cyclopentane. What do you mean by cyclopentane, students? Cyclo, okay, it will be in cyclic form. Pentane, okay, so it will be in pentane form. So 1 carbon, 2, 3, 4, and 5. Okay, so 1, 2, 3, 4, and 5. Fine. Now here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so so these are the hydrogens which I have written here. Okay, on this. So these are the hydrogens. So this is what? Cyclohexane. So in ring structures, we write mostly the cyclopropane, cyclobutane, and pentane, cyclohexane. Okay. Now, what is benzene structure? So in benzene structure, you have alternatively a double bond. There is a presence of double bond. So you have single hydrogen. So when you write the structure, you can see that carbon will have 4, right? So so if I write in the carbon form like this, I'll write it here properly, beta. I'll take a dark color. Okay. See here. So carbon, 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 and carbon. Now, as I've said, alternatively, there will be a double bond. So here one double bond, here one double bond, and here one double bond. Now here one single, single, and single bond. Okay. Now we'll arrange the hydrogens. Now see here, carbon, 1, 2, 3, only 3 hands. So again, one carbon, 3, 1, again 1. Okay, so each carbon atom will have how many valency? It is having how many? 4 valency. Okay, so like this. So this is the structure of benzene. Got it? So this is the structure of benzene. Okay, fine. Now, so when you have a hetero group atom, when you have a hetero, what do you mean by hetero group? Hetero atom means other than carbon and hydrogen. Okay, when you have other than carbon and hydrogen, when you have other atoms, then they are called as heteroatom. Remember, what do you mean by heteroatom? Hetero means other than carbon and hydrogen. Okay, now till now, did you see in alkanes, alkenes, and alkynes? There are all the carbon compounds. They are made up of carbon and hydrogen only. Okay, heteroatom means what? When you have sulfur, nitrogen, oxygen, chlorine, fluorine. Okay, so these are the heteroatoms other than carbon and hydrogen. So these atoms are called as what? These atoms are called as heteroatom. Okay, these are called as what? Heteroatom. Fine. Now, which functional group it will belong to? Okay, if you have a heteroatom. Now, whenever you have a chlorine, you have a chlorine. Now, whenever you have a chlorine, what will happen? Yes. Whenever you have a chlorine or bromine, okay, then the functional group present will be what? It will be a halogen. Okay, you have a halogen, that is chloro or bromo is having what you will be having? You will be having a or bromo group. Okay. So whenever you have a chloro or bromo, then they are called as halogens. Okay. They will have a functional group halo. So if you have a Cl, then it is called as chloro. If you have a Br group, then you have a bromo. Okay. So this is the formula of the functional group. Okay, so halogens, they are represented by X. They are represented by X. Okay, so if you have chlorine, then you will be writing as Cl. If you have a bromine, then you'll write as Br minus. Okay, now, so this will substitute your hydrogen atom. So suppose you have a methane. Okay, then one of the hydrogen atom can be replaced by what? Cl, like this. So this can be a halo compound like this. Got it? Fine. Now, whenever you have oxygen, when the heteroatom is oxygen, when oxygen is present, then what will happen? The functional group can be alcohol. The functional group can be alcohol. It is represented by what? It is represented by OH. Okay, OH is the functional group for alcohol. Aldehydes. Okay, aldehydes, you have CHO. Okay, you have CHO. You can or else you can write it as C double bond OH. Okay, so aldehydes. So in aldehydes also you have a heteroatom oxygen. Now ketones is represented like this. Okay, C double bond O. C double bond O. So you have a oxygen atom. Carboxylic acid, C double bond O, OH. Okay. C double bond O, OH. So this is all the functional group and how do you write the formula. I hope you are getting it. Okay. So whenever you have a heteroatom, so you have different functional group and their formulas are also different. Fine. So these are some of the alcohols. Okay, so these are some of the alcohols. You can see here. Okay, so we'll see this. So alcohol, when you have a carbon atom, okay, one carbon atom, then as you know, it is called as meth. What they are called as? It is called as meth. Okay, okay. Now for alcohol, the suffix is ol. Okay, the suffix is ol. So it is methanol. The name will be methanol. Okay, so CH3. it will be substituted by OH. So this is the structural formula, that is CH3OH. Okay. Next, when you have carbon N is equals to 2, okay, then it is eth, right? But you have alcohol, so it is ethanol. Okay, so the formula becomes CH3CH2OH. Okay, the molecular formula becomes CH3CH2OH, and this is the structural formula. This is the structural formula. Then when N is equals to 3, when N is equals to 3, what is the name? It is propanol. What is the name? It is propanol. Okay, that is CH3, CH2, CH2OH. Okay, CH3, CH2, CH2OH. So this is the structural formula is, this is the structural formula. Please go through the structural formula. Next, when you have N is equals to 4, the prefix is but, okay, and the alcohol, so it is a butanol. Okay, it is butanol. So the number of carbon atoms are 4. 1, 2, 3, 4. It ends with OH, so it is butanol. So the structural remains the, okay, so there will be addition of 1 carbon with 3 hydrogen atoms, 2 hydrogen atoms, okay. Next is when N is equals to 5. What is the compound? The name is pent. Okay, pent, and it is alcohol, so it is pentanol. So the number of carbon atoms are 5, CH3, CH2, 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 OH. Okay, so carbon, 5 carbon atoms, 5 carbon atoms, then 1, and it is substituted by OH. Okay, so it is CH3, CH2, 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 and OH. Okay, got it? So this is the alcohol series. I hope you have got it. Yes, students? Yes. So so these were the things which we have studied today. So in today's class, what all things we have covered? We have seen the homologous series. Okay, we have seen the homologous series. So what are homologous series? And we have seen the homologous series for alkanes. We have seen the homologous series for alkenes. Okay. Then we have seen the homologous series for alkynes. Okay. Then we have seen the different functional groups. Okay. Okay. Then then we have seen the homologous series of alcohols. Okay. So any doubts, students? Any doubts? Yes. So these were the homologous series. So in the next class, we are going to see these particular series. Okay. So that is aldehyde, ketones, okay, carboxylic acid. Okay, so these all things we are going to discuss in the next class. I hope today's session is clear. Yes? Okay. So I'll end the session here. So we'll be meeting in the next class. Thank you.